Hi guys, I'm just recording another audio so that I can explain Weinstein's theory of everything and just try to make a little bit more sense than what I explained last time. So, in order to explain it and make a little bit more sense, I'm just going to explain about three things. One, what is the theory of everything? What does it have to do? And how does Weinstein try to make that happen? Okay, so a theory of everything basically is the shorthand way of saying a theory that combines the standard model of particle physics and a theory that combines gravity. So the standard model, when a lot of people think about the standard model, you look it up on YouTube and you see something about all the different uh, constituents of atoms. So, whether that be the quarks or it be the bosons or the fermions that are interacting inside the atom that make it what it is. But that's not everything there is to know about the standard model. So the standard model, it basically explains that all of matter exists in something called a field. So this field it permeates everywhere and everything. At every point in space-time, there is this field. And that field is basically like kind of like a pocket dimension, where at each point in space, there's this little pocket of dimensionality, and this dimensionality holds charge and the other properties of each particle. So as it passes through, it's kind of like the digital display on a screen or uh, anything like that, where essentially it is capable of holding that charge or the property of that subatomic particle, and that's basically it. So you have these little pockets in in the fields, and what you're trying to do in a theory of everything is you're trying to get gravity to somehow interact with why these fields exist or what gives them their properties, um, so that we can have matter itself. So basically, summarized, that means that the standard model means if we have fields, we can have particles that have properties. And if we can have particles that have properties, we can have matter and we can have energy transformation between different uh, different elements and different atoms interacting with each other. So when it that's what okay, so let me go back to the start. So a theory of everything is basically the standard model interacting with gravity, um, and it has to create basically the standard model. And however you're doing it, has to explain how the standard model interacts with gravity. And basically, Weinstein attempts to do that in a specific way. Okay, so what way does he do it? He he starts off philosophically. So he starts off thinking, what does a theory of everything have to do? What are the possible ways to solve this? How have people solved it before? How can I attempt to solve it differently? What do I believe would be the ideal way to come at this? Is there any way that I can create some kind of problem, some kind of logic problem that gives me a way to think about how we can create this solution? And basically, what he sets out to do and starts with is he says, what I want is I want something really simple. I want something so simple that if you ask the question, yeah, but how did that come into existence? That it's not really a problem, that you would just be like, okay, well, it's the simplest possible thing. So, well, there you go. So, for example, the Big Bang, it's complicated because then you're like, well, where did all the stuff come from? Why did it explode? Was there anything before the Big Bang? It's kind of a thing where it is very simple and it does explain a lot of things, but it's not so simple that it's just, well, that's self-evident. It would create itself. Of course, if something had to exist, it would probably exist like this. So he tries to think of something simple enough that if it exists, it wouldn't be a question. You wouldn't question like why that exists. Now, if he actually achieves that or not, that's a different thing. I mean, you can have your own opinions on that. I'll explain it in a bit. Um, and he tries to think, well, the very end goal of a theory of everything is that you create the standard model, um, and that you also involve gravity at some point during that, and they have to be intimately connected in a certain way. And if you accomplish that and it makes sense, and you're not manufacturing the way that they interact with each other, so that you know all the different constants that you use to calibrate the two theories together. He basically doesn't want those to be manufactured. So he wants something organic that is very simple, and that sort of implies itself somehow. So it sort of uh, leads to its complexity, all on its own. So it's kind of self-emergent. Um, So that simple thing interacting then creates a dynamic, and that dynamic then um, creates the connection between gravity and the standard model. So the fields that give matter properties. And so to do this, what he does, or his eventual solution, or one of his solutions, is that he starts with space-time without it being like the space-time we know. So the space-time we know, there is forwards, there's backwards, there's sideways, up, down, and things can fit in it. And if they fit in it, there's not going to be any distortion. It's not going to be weird. It's like a very calm lake. You can swim in it, and it's fine. What he's proposing is something much like a storming ocean, within that's swelling, that has currents, that is wild, and he calls this proto-space-time. So this space-time, you can't measure it straight from one end to the other, because if you do that, time interacts with itself, space interacts with itself, and you won't get the right answers. So he's basically saying proto-spacetime, spacetime that is almost impossible to measure, or doesn't have measurements that you can put on it because it's too primal, or it's just not constrained. It's not unified. It's not harmonious like the spacetime we have right now that we experience. He says, no, it's primal, it's weird, and it's not even necessarily all, it's not even necessarily 3 of space, 1 of time. It might be 3 of time, 1 of space. It could be any sort of variant of that. It could even be fluctuating between them, where it's fluctuating, like some is 2 times, some is 2 space, one is 1 time, 3 space, and there's 3 time and 1 space. And all of those have the same sort of range of freedom to them, but they're just organized in a different way. And he's basically just saying that it's kind of weird. He calls that proto-spacetime. So he says, well, that's cool, that's interesting. You could have a four-dimensional proto-spacetime and just be like, okay, great. That seems pretty basic, but also very dynamic, and it could potentially do something. So then what he says is, let's bring in a second proto-spacetime and have them interact. So he has a proto-spacetime that's kind of turbulent. It's not like a calm lake, it's like a storming ocean. And the second one starts to interact with it. Well, that's going to create interference patterns. Just like two different waves interacting with each other create interference patterns. These two proto-spacetimes are going to create interference patterns with each other. And what that essentially does is creates the potential to create these fields. So if you imagine it like as they snap together, it creates this bubbling or this frothing that is consistent along a specific plane of of them interacting, clashing. So as waves hit into each other, there's a certain section of it that is white water, while the rest of it, it's still the stormy sea. And basically the idea of it is along that stretch that creates that white water, uh, you get this um, fine mesh of interacting space-time that is sort of interweaving into things. And this is possibly the creation of the fields required in the standard model. So he's basically saying that as two proto-spacetimes interact, they create this froth that creates fields that are required for the harmonization of space-time. So space-time becomes uniform, it becomes more understandable, more rational, because the impact between those two has caused it to have this uniform, outstretched sort of property to it. And essentially, the world and the universe that we see and can interact with is along this band of white water. And while that isn't the entirety of the universe, it's the universe that is coherent. So we can only interact with the universe that is coherent, not the incoherent proto-spacetimes that exist outside of it. So he's saying those incoherent proto-spacetimes do continue to exist, but there is basically a section of interaction where the dynamic between those two creates a coherent field space that has space and time sort of coming out of it in a uniform way. So if you imagine there is like this just storming water, and then you put it through a funnel, and through the funnel it comes out as a stream or a jet of water. It's kind of similar to that idea. Or you have storming water that goes over the edge of a waterfall, and as it goes over the edge of the waterfall, it might be uniform for a period of time as it's going over that waterfall. So you have this section where it is essentially where it is harmonious, predictable, sensible, but the rest of it isn't. So the top of the waterfall, like as it's the river coming into as it's the rapids coming to the edge, it's turbulent. But as it goes over the edge, it has like nice laminar flow. It's very smooth. And then as it continues to go off the edge, then it's chaotic again. So it's basically saying that proto-spacetimes could interact with each other in such a way that they could create the fields that are required for the standard model. And because the fields themselves are then created out of space-time, it provides the connection between gravity and matter. So essentially, matter is gravity, but it is only gravity because of its history and its future. So in its history, it was a mass of proto-spacetimes um, that are about to weave into each other. And in its future, it is a mass of spacetimes that proto-spacetimes that is about to diverge from one another. And essentially, you can look at this a few different ways. You can look at it from the perspective of being inside that nice, smooth section. And then you can look outside of it and say that everything else is chaos, or you can look at it from the chaos and look in on the smooth flow, and you can see those two things as having like they're inherently different. So what he says happens is that there is a world of physics in the proto-spacetimes as they interact with each other that is completely external to the universe we experience, but that those laws of physics that are happening in the proto-spacetimes as they interact, they're also happening in the quantum world where all the different particles are interacting as well. So he's basically stating that there is a space of physics outside of our universe that is also sort of filtering in through the fields that create matter. And that essentially that turbulence, that proto-spacetime turbulence, is also enmeshed inside of the fields that create matter itself. So essentially, outside of us, outside of the universe, there is this chaos, but the universe itself is calm, still, serene, but turbulence at its heart, at its core, and very, how would you say it? Like it's very explosive and capable and full of potential because of those interactions being what's actually at the heart of things being more harmonious and simple and explainable. So I believe he thinks that is one of the simplest, clearest ways that the universe could exist. That it's essentially two simple things merging together to create in between them something something harmonious, something that makes sense, something that's mathematical. And in a way, it's similar to membrane theory, where you have these two different membranes and they merge together. So the M theory, right? But I think the real the real work of it comes from how he then tries to turn this into geometry. Um, so using fiber bundles and that sort of thing to show how these two proto-spacetimes as they interact can create something similar um, to the standard model. So what he tries to do is he just tries to show that through 128 spin, S10, that basically it just means that by using spin, which is a property of fundamental particles, and different versions, like one specific version of the standard model, like there's different variations, there's different ways you can look at it. So he creates one of those and says, well, coming out of the fiber bundles and how they're interacting with these proto-spacetimes, I believe that you can get the standard model as well as the theory, the equations of motion. So the equations of motion are, you know, Einstein's theories of relativity and how, you know, bodies will move around suns and black holes and all that sort of stuff. So he's basically saying you can get both equations, both mathematical ideas from this genesis. And that's pretty much how much of it I understand. Um, so, just the simplest version of understanding Weinstein's theory is that he's essentially saying these proto-space times smack together. It creates a lot of chaos, but also this fine chaos creates a kind of a section that you can take out of it and you can say, okay, this is the universe, or it's the basis for the universe, and then the universe can be created from those fields that are created in it. The fields themselves, because they're weaved out of space and time, they essentially, we live on the three space, one time filtered section of that. But we don't live on like the 3 time 1 space section of that. So he's saying that essentially there would be different variants of that interaction of those proto-space times as they collide together. But we, by necessity of our intellect, require 3 space and 1 time to have our biological bodies, to have the world that we interact with. And so essentially, we're selectively um, existing in this version of events because that's what's required for biology. Um, and that's the basics of the theory. And no alarm clock, no no smoke alarm this time. So I hope that helps you guys. Um, I will explain some more stuff probably in the future. Probably I don't know if it's in the short-term future or anything, but yeah, I just hope that helps you figure out and understand the basics of what's going on. Just as a little added aside, um, Weinstein's theory, like my personal opinion, is that it actually has some really cool um, elements to it. So for myself, I like science fiction writing. I like to think outside of the box, and so I can appreciate this idea as just an idea, essentially. Also, sometimes ideas can lead to other people figuring out better ways to express it or clarifying it. I don't think Weinstein himself wants anybody to clarify it for him unless they give credit, um, which is fair enough. He's in that position and he doesn't necessarily want to um, end up creating something profound for the world that's, you know, that somebody else comes along and takes credit for. Um, which does make a degree of sense because it's difficult to connect with people, difficult to get traction on an idea, and he feels that when he does get traction on the idea, he's probably going to do it the wrong way. Someone's going to steal the idea, and then it's all over. So he basically just wants, I don't know, that recognition for being able to think outside of the box and to be able to create a framework for investigating the theory of everything. And I believe that the framework is, in a way, more important than the answer he provides. And the framework is that think of a simple way that um, that you could create the two outcomes that you need. Start there from those simplest outcomes. Don't be constrained by space and time, having to be very specific, and also look at the idea of the intermingling of space-times, proto-space-times, as to how they can create a standard model with fields and the equation of motion. He also suggests that you require the spin, so 128 spin, interacting with those things. He says that he previously had all the equations needed to understand this. He might have them, um, but he just doesn't want to create them again or something. So, I mean, take that for what you think it's worth. Personally, from a science fiction perspective, which is kind of interesting to me, and I'm also like learning mathematics, and I find interesting mathematics helps you sort of pursue, um, understanding. Like it gives you more of a goal. It's more exciting, more interesting. Anyways, so I think it's interesting because it provides the idea that the world that we live in isn't necessarily everything of the universe, and that at every point in space where there's matter and gravity, there is connected to it um, a kind of stream of time and space that we don't interact with, a kind of chaos that is weaving into the very nature of matter and um, everything around us at all times. So there's almost like there's these streams coming in, or these winds coming in from outside of the universe, affecting everything that you see and then passing through it, without it affecting what you can measure, what you can see, except in certain circumstances. So, I mean, it's why things are the way they are. So, I think that's very interesting. It's a bit like bubble gum or something where you've chewed up the gum and then you can blow a bubble into it, and then the bubble has shape and form. Um, Instead of a bubble, though, you're getting these pocket dimensions for fields that allows you to have matter, which then has this equations of motion that can also be created in that mesh of that like chaos as it's interacting. And I think that's very interesting. I think it's a very creative way to look at things, a very mm, it's kind of like wild, creative, sort of like thinking uh thinking like stretching your capacity of thought around those ideas, and I think that that is probably the biggest step forwards. Is I think he's actually right in that you do need to stretch your mind to set out different rules, to break certain rules, and to consider things from first principles rather than thinking of things from like we know the standard model, we know um, the we know relativity. Let's just stay on that. Let's just try and work those two together. He's saying break out of that and start to think what are those symptoms of? They could be symptoms of a lot of different things. And potentially to make that make sense and to make that coherent, start with the idea of geometries, simple geometries, then inject enough mathematics, like fiber bundles, to help you understand how you can get to those eventual symptoms. And that's kind of what he's really sort of suggesting at the heart of it, is that instead of string theory, which is he created all these ideas when string theory was becoming popular. He was like, no, 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 string theory, no, 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 no. And I think he was creating his own version of that. And so he was going off what by gut instinct felt more correct to him. So he says, like, that has problems, this has problems, that has problems, as a kind of critic, right? And he says, well, what if we did it more this way? This seems more correct. So he hasn't pulled away from the idea of the standard model and said something like, oh, it's something different that's actually happening. He hasn't gone away and said, you know, Einstein's wrong, blah, blah, blah. He's basically saying what we have seems to be pretty correct, but our expectations of what creates that is very likely wrong. So he's basically saying that the expectations of the scientific community are likely very wrong, and that they should be able to get away from that and stop thinking uh, dogmatically about um, that they that you can manipulate science, that you can manufacture it. So he believes that there has to be a source, there has to be an origin, there has to be some sort of organic interaction that creates those things, that those things can't exist on their own, and that if you manufacture answers, those manufactured answers are going to be less robust than if you essentially start from a platform of asking questions about the very fundamentals that can then evolve into the thing that you see. I think a lot of scientists out there are smart enough to kind of understand that. I think the theory needs refinement to get it to be cohesive, coherent, completely. Um, but it's really interesting. It's really interesting. There are other people out there that have interesting theories as well. Um, and I think it takes people to start stretching their minds to start to understand how things can work differently. Personally, I really like his theory because to me, it says that the very fundamentals of physics are potentially changeable or are different in a different part of the, like, if you can imagine it's an ocean of proto-space times interacting with each other, there's the peaks of the waves that create these um, harmonized areas that can create fields. And just outside of that, the physics will be different. And then further out into like the still part of that ocean or smooth part of that wave, the physics is going to be different there as well. So it kind of sets up this idea that physics could be manipulated, but if you manipulate it, it might not impact the world we live in. So you need to understand the constraints of the structure of our world that we interact with, while you start to understand that things can be different just outside of our reach. And potentially, if you start to think about what's just outside of your reach and how you can translate that back into our world, and then use our world to translate back into what's just out of reach, that essentially you could create this feedback loop between different physics happening outside of our universe, impacting the physics inside of our universe, And potentially you could utilize the physics, different physics outside to impact ours. So essentially what it would be is in our world, we do have entropy, we do have the second law of thermodynamics, we do have limits on basically traveling through space and time. And it is possible, if you understand that there is a spectrum of physics, we exist in one specific layer of that. And if you could get that to interact with one just slightly outside of what we interact with, and get there to be some sort of feedback, you could potentially influence thermodynamics, potentially limits on the speed of light, and so on. And that's what's really interesting about it, is it doesn't set those kind of limits. It suggests that you potentially can change things, and that ultimately proto-spacetimes may be the only way they can interact, is interact in such a way that they create our reality, maybe. But maybe there's different ways, different proto-spacetimes could create different realities that have different properties. And that is also interesting, because what might make sense of the physics of our world potentially could be slightly altered or slightly different um, at some other place in some other universe. Or, I mean, his theory doesn't necessarily have to create multiple universes or anything, but his theory could essentially state that a different part of the universe could have different physics, maybe. It just depends on your interpretation of it, whether you think that the uniform way of how it creates fields is something that necessitates a completely uniform and coherent universe, or whether that universe itself is then also going to have different patches of different physics bleeding into it and bleeding out of it. So I don't have 100% confidence that this is exactly what he's saying, but it's the best interpretation I can say of it after I studied it for a bit, 3 months, I'll be honest. Just trying to break down everything he said and how he meant it. And that's the most basic way I can explain it for people. And I hope that helps. All right, peace out.